Older homes were not designed with noise tolerance in mind. Before electric hums, traffic, and constant mechanical vibration, nighttime silence mattered because, well, sleep was directly tied to physical survival, recovery from labor, and long-term health. Builders worked with materials and layouts that naturally reduced sound transmission, not as a luxury, but as a functional requirement. Walls, floors, ceilings, and even room placement followed patterns that created quiet by default rather than by technology. Thick walls were built to absorb sound, not just hold weight. Pre-war homes commonly used masonry, solid timber, plaster, brick, and lime-based mortars. These materials are dense, irregular, and heavy. Sound loses energy when it moves through mass, especially uneven mass. A 12-inch masonry wall or a plaster-on-lath wall dampens sound far better than modern hollow drywall cavities. The uneven texture of lime plaster and wood lath breaks up sound waves instead of allowing them to travel cleanly. Today, this principle can be applied by adding dense layers like plaster skim coats, lime wash, or secondary mass-loaded panels rather than relying solely on foam or fabric treatments. Floor systems were designed to stop vibration from traveling upward. Older homes often used thick joists, wide plank subfloors, and layered flooring assemblies that slowed vibration. Floors were not engineered to flex, they were built stiff and heavy. This prevented footsteps, creaks, and low-frequency vibrations from transmitting between levels. Many early floors also included packed ash, sand, or debris between joists, unintentionally creating a sound-dampening layer. Modern homeowners can replicate this by stiffening floor systems, reducing flex, and adding dense underlayment rather than lightweight padding. Ceiling height and room volume helped dissipate noise naturally. Rooms in older homes often had higher ceilings, not for luxury, but for airflow and thermal control. Higher ceilings also reduce perceived noise by increasing room volume, allowing sound to dissipate rather than bounce aggressively between surfaces. Sound energy spreads out instead of concentrating near the sleeper. Even in smaller spaces, older homes used angled ceilings or exposed beams that broke up sound reflection paths. Applying this today means avoiding flat, hard ceilings directly over sleeping areas and introducing texture, depth, or diffusion above the bed. Sleeping spaces were placed far from active zones by design. Bedrooms in older homes were intentionally separated from kitchens, workshops, and gathering rooms. This zoning was not aesthetic, it was practical. Noise from cooking, wood chopping, tool repair, or early morning work needed to stay isolated. Hallways, stairwells, closets, and storage rooms acted as sound buffers. Applying this knowledge now means, well, rethinking bedroom placement, even within an existing home, by using buffer rooms, thick wardrobes, or storage walls between sleep areas and noise sources. Doors and thresholds were built to seal rather than swing freely. Old interior doors were solid wood, often thicker than modern equivalents and hung with tight tolerances. Door frames were deep and thresholds were raised. This limited air movement, light, and sound transfer. Curtains or secondary doors were sometimes added in colder regions, doubling as sound barriers. Today, replacing hollow core doors with solid wood or adding weighted curtains over doorways can dramatically reduce nighttime noise without relying on electronics. Windows prioritized insulation over openness. Before large glass panes became affordable, windows were small, thick, and often double-layered with shutters. Wooden shutters, internal or external, blocked wind noise, animal sounds, and early morning light. Storm windows were common long before modern glazing. Applying this now means using interior shutters, secondary glazing panels, or heavy-lined curtains rather than relying only on modern window replacements. Well, soft interior finishes back then were really functional, not just for show. Folks used rugs, wall hangings, tapestries, and thick bedding, and it wasn't only about keeping warm. These things helped with sound control too. Bare walls? Those were pretty rare in sleeping spaces. Textiles like these actually absorb mid- and high-frequency noise, cutting down on echoes and those sudden sound spikes that can jolt you awake. Beds themselves were massive wooden structures, stacked with layered mattresses, straw ticks, wool pads, and heavy covers, all of which soaked up movement and sound. If you want to get a similar effect today, you can layer natural fibers like wool, cotton, and heavy quilts, rather than going with those minimalist bedding setups. Structural irregularity, believe it or not, actually helped reduce sound reflection. Older homes, well, they were hardly ever symmetrical inside. You'd see beams, alcoves, built-in cabinets, and uneven wall planes that broke up the path of sound. This kind of setup prevented standing waves and echo chambers from forming. See, smooth, box-like rooms just amplify noise, while irregular spaces tend to soften it. These days, you can recreate that effect by adding things like bookshelves, built-in storage, or textured wall surfaces, and you don't even have to change the actual structure. Back in the day, nighttime routines were really supported by the house itself. Homes were designed to quiet down as the day ended. Kitchens would cool, fires would die down, and shutters would get closed up tight. The structure worked right along with the rhythm of sleep, rather than fighting against it. Even floors creaked less in sleeping zones, since traffic paths were predictable and limited. If you want to apply that today, it's a good idea to cut down on unnecessary mechanical noise near sleeping areas and let the structure itself do more of the heavy lifting. What modern builders removed that older homes understood is honestly pretty eye-opening. Modern construction, it tends to prioritize speed, cost, and those open layouts everyone seems to want these days, but lightweight materials, well, they transmit sound real easy. And those open-plan designs, they just let noise travel all over the place, unchecked. Thin walls and hollow cavities, they act like echo chambers, amplifying every little sound. Older homes, though, they avoided these problems by using mass, separation, and texture. Now understanding this lets modern homeowners and preppers retrofit their spaces intelligently instead of just chasing the latest gadgets. So, how can preppers and folks with a love for history use this knowledge right now? Well, quiet sleep is actually a form of resilience. It helps with decision-making, reaction time, and even long-term health, believe it or not. Adding mass, separating spaces, sealing up gaps, and using natural materials, these are low-tech, durable solutions that'll still work if the power goes out or during long-term disruptions. Best part is, these methods don't need any maintenance, electricity, or constant replacement. Why does this knowledge still matter today? Well, older homes solved these problems for good, not just for a little while. Silence was built right into the structure itself. For anyone interested in preparedness, sustainability, or a bit of historical design wisdom, these principles offer reliable solutions. Ones that, honestly, modern technology often just complicates rather than improves. If this kind of deep historical insight matters to you, go ahead and subscribe to Warfield Prepper Chronicles. Share this with others who value real-world knowledge and, well, keep these methods alive by applying them where you live.